Good day, students. My name is Deborah and today I'll be taking you through valley climates in the Grade 12 Geography series with SMAT Prep. Don't forget to like, share, and subscribe, and we'll get right on with the video, right? So in this video, our learning objectives includes looking at the valley climates, obviously, and looking at things like Anabatic, Katabatic winds, inversions, frost pockets, radiation fogs, slope aspects, and their impacts, and we'll look at the impacts on humans, settlements, farming, and the environment in general. Alright, let's get into it. So now we'll look at some of the definitions of some terms, right? So we'll begin with anabatic wind, which is a local wind that blows up the length of a valley during the day because of the rise of warm air, right? Now contrast this with katabatic winds, which are local winds that blows down the slope of a valley during the night because of cold subsiding air. So the difference is in the type of air that is blown in, whether it's day or night, right? And then downslope winds is a local wind that blows down the sides of the valley during the night. So in a katabatic wind, we would have downslope winds. And then frost pockets, an area of cold air reaching a dew point temperature below freezing that is found at the bottom of the valley. And this may occur on clear, calm winter evenings. And then we'll look at microclimate, which is a climate of a small area that is different from the climate of its surroundings as well. All right. The next definition is radiation fog, which is fog that forms at night under clear, calm conditions. And a fog is caused by condensation in the air that is cooled to dew point temperature as a result of a loss of heat through terrestrial radiation. Now we have shadow zone, which is a part of a valley that does not receive any sunlight. Then when we talk about slope aspect, we're talking about the direction to which a slope faces. We also have temperature inversion, which is an increase of temperature with altitude rather than usual decrease. And we talked about it in the previous video as we looked at the effect of that temperature inversion and the anticyclones as well. Then we have thermal belt, which is the warm layer of air midway up a valley with cold air below it because of that inversion of temperature. And lastly, we have upslope winds, which is a local wind that blows up, the sides of a valley as opposed to down it, as with downslope winds. All right. The next definition is aspect, which again, as we said, refers to the direction in which a slope faces. Now, this impacts changes during winter and summer because we have migration of pressure systems, as we discussed in previous videos, as well as the angle of the incoming sun, and we will go on to see what that looks like in northern and southern hemisphere and the type of slope as well. And now we'll look at the associated weathers that might occur in the southern hemisphere, looking at the north-facing slopes, right? So north-facing slopes are usually hot, sunny, and dry, and they usually receive more of the direct sun's rays, right, as you can imagine. So we have a smaller surface area that is being heated and thus that becomes warmer. The soils are also warmer, and therefore farmers usually will select the slope based on obviously the type of crops that they want to plant. And then the warmer part of the valley is called the thermal belt, which we've defined earlier. And then the effect of this aspect is greater in winter, right? And then in places furthest away from the equator as well, when we consider north-facing slopes area. All right. Now, when we contrast this with south-facing slopes, right, you can look at the image as well. We can see that the areas are usually cool, shady, and then they retain moisture. And then the soils are cooler on the south-facing slopes as they are now in the shadow zone, because remember we talked about this as well. And then areas in the shadow zone on the south-facing slope are usually only heated by reflection. So you can begin to see and appreciate the difference between an area that is facing the north and those that are facing the south. Alright, so this is an image that might be easier. They might ask you to draw the difference of the influence of aspect on the north and south facing slopes in the southern hemisphere. So again, quick summary. For north facing slopes, we have direct sun's rays, there's a smaller surface area, and then that slope is therefore warmer. And then in south facing slopes, that's more the shadow zone. There's a larger surface area, it's indirect heating, and then it's cooler slopes, alright? So that's the contrast between the two of them. So now let's quickly define the impact of the slope aspect, right? So normally humans will build their houses on north-facing slopes because again, that'll be a warmer region. And then crops that might require less moisture and more sunlight will also be planted on the north-facing slopes. South-facing slopes are usually too cold, right? And so we don't tend to have houses that are built there. And then, however, trees and shade-loving plants might, grow on that places because of things like, think of things like ferns as well that might prefer those regions, all right? Now let's contrast and move on to anabatic and katabatic winds, right? So we defined them earlier, but then with anabatic winds, the air above the slope warms and that becomes, less dense and rises on the slopes of the valley, right? This is a warm wind which blows up a steep slope or the mountainside, driven by the heating of the slope by insolation. So there's a warm air that rises up the valley slope, right? And it usually occurs during the day because of the heating and insulation that occurs, right? So you can see from the image there is that clockwise circulation of the warm air as it rises, as the slopes are being heated up as well. And in katabatic winds, on the other hand, the air above the slopes becomes cold and dense, and then that descends down the valley slopes. This is a wind that carries high density air from a higher elevation down a slope, and this is under the force of gravity. It occurs at night when the slopes cool down due to terrestrial radiation. So you begin to see also the difference, right? Terrestrial radiation for katabatic winds and insolation for anabatic winds. And you can also notice that the wind circulation is more anti-clockwise in this region at night, right? Alright, so this is just a consolidation of the diagrams, right? You can see the patterns of the airflow during the slopes and anabatic winds, the slopes, during the day rather, the slopes and air above it are heated, therefore warm, less dense air rises up the valleys. In contrast with katabatic winds, the slopes above and the air above is colder, so that air descends and forms katabatic winds, alright? Now, if you speak of the impact of those types of winds, anabatic winds, because they arise in the air, it removes the pollution in the valley to higher altitudes, right? So whatever pollution is condensed earlier will be risen up. And then katabatic winds, the descending air is cold and therefore there's a trapping of the pollution on the valley floor, which will result in the development of smog, thermal belts, and frost pockets instead, right? When we talk about inversion layers, they usually occur during calm, cold, and clear winter nights. So when the cold air drains down the valley slope, and it then collects at the valley floor, right? The warm air is displaced upwards to form an inversion layer in the mid of the valley, and it's a layer of warm air that's trapped between two layers of cold air, which results in the thermal belt formation as well. So this can lead to the formation of acid rain that corrodes buildings and damages crops, right? So you can see from the diagram on the right the effect of the temperature. As the temperature is changing, the warm air sort of trapped between the cool air, right? And again, this is another image that explains this better. So at night, the cold katabatic winds subside into the valley, and then the warm air at the bottom of the valley is therefore forced to rise, and this forms that warm thermal belt, as we mentioned it before, or the inversion layer as well. So the pollution from buildings can also be trapped as an impact, right? The next thing we'll look at are frost pockets, which is a low-lying area of valley floor where the frosts occur more frequently than in the surrounding high-lying area, right? So this is normally after a dry, clear, and cold night. The cold air drains down the valley slopes, and then if the dew point temperature is below the freezing point, we therefore have condensation to ice crystals, and this forms frost pockets where the cold air collects, right? So you can see from that the image, there's a difference between the thermal belt, which occurs in the middle, and then the very cold temperatures are below, right, the valley or on the valley floor themselves, and you can see areas where there would be frost potential or frost dangers. Now, building up on the concept, we look at radiation fog, right? So on cold, clear, cloudless nights, when rapid terrestrial radiation occurs, the ground becomes cool at night, and then the air above the ground is also cool. So as discussed earlier, when the air is below the dew point temperature, which is above 0 degrees Celsius, it causes water vapor to condense around the dust and the smoke particles in the atmosphere, and this causes radiation fog. So it's just a mixture of the water vapor, the dust, and the smokes. And then in the morning, the sun hits the surface, which causes the warm air to rise and evaporate. And now, in combination with the pollution in the atmosphere, we therefore have smog, right? So the smoke and the fog together, right? So now let's look at the impact of inversion layer, frost pockets, and radiation fog on humans and the environment. So when you look at humans, right, the frost pockets can cause people to settle mid-slope in the thermal belt because that is warmer than in the frost pockets themselves. Smogs themselves can result in poor visibility and is probably a health hazard, and this can also result in traffic accidents due to poor visibility as well. It also affects people's health, particularly the respiratory illnesses. And then in the environment, we have trapping of pollution from industries in the area. We can have things like acid rain, which will also damage our fauns and flora. It can also affect farmers if the frost-sensitive crops are grown on the valley floor themselves, and therefore farmers have to invest in planting frost-resistant crops. And then we could also have damages to the natural vegetation and crops. All right, so now we move on to some questions about this. All right, so now we're going to go into the activity, and I'm going to set the 1 minute timer for you to attempt the questions on your own. All right. All right, so the first question says, what is the zone where warm air mass is trapped between colder air mass, right? So that is obviously the thermal belt zone. And then a mixture of smoke and fog, as you can imagine, would be smog. So you had to choose from suitable words from that block that match with each sentence, right? In 9.1.3, the direction in which the slope faces in relation to insolation is the aspect. Forms when calm conditions and clear skies occur in a valley, that is your radiation fog. And then forms on the valley floor when the air temperature is below freezing point, that's your frost. The type of winds that result from air sinking down the valley slope at night is Katabatic winds. And then the type of wind that results from air moving up the slope during the day is Anabatic winds. So remember the contrast between Anabatic and Katabatic. Katabatic being at night down, air sinks down, and then Katabatic, or Anabatic rather, is when air moves up the slope during the day. All right. Okay, now we're going to look at another question. You can see that we have descending air. It's mostly at night. Looks like it's at night. We have A, and then we have point B as well. We have fog that exists within the valley floor, right? So it says, is the slope wind at A an anabatic or katabatic wind? And again, please feel free to pause the video to attempt it yourself. But with slope A, we can see that it's a katabatic wind. Why? It's cold descending air that is occurring at night, right? That's the definition of katabatic winds. So if the arrows were going up, we could assume that that's anabatic winds. And B, above the valley floor, is a thermal belt. Give a reason for the statement, and it's because the temperatures are above freezing point. And then what is the term used to describe an increase in temperature as the height increases in the valley? So that is your temperature inversion. So remember that normally we have temperatures that decrease as we go up, right? The higher you go, the colder it should get. But here in the valley it's different. And explain why slope wind A will be more intense in winter. And think about it, winter is generally colder, so there's colder air that is descending, and that is in contact with the slopes, which would cause the temperatures to now drop really below freezing point. And also, slope A is a south facing slope, and then in the southern hemisphere, that's also generally colder. So you can choose any of those reasons, any of those two reasons, or any two reasons, and that should help. And then we'll look at the last question about the low temperature that is likely to be experienced at the valley floor and the methods that the farmers can do to adapt, right? So in this case, the low valley temperatures could be because the temperatures will be below freezing point because of the cold descending air. As we said earlier, frost pockets will form as a result of temperatures that are below freezing point. Then, so for the methods, right, the crops that cannot withstand frost will be planted on the north facing slope because we said south facing slopes are generally colder. So north facing one would be warmer. The frost-resistant crops, such as deciduous fruits, will be grown on the valley floor instead because they will thrive there. And then the cold conditions and frost will kill pests, which is a good thing. And then the cold conditions suit the growing conditions of those crops. Right, so any of those four reasons would have been suitable. Okay. Alright, so the next question is 9.3. Again, please feel free to pause, but I'll continue to answer them. So we see slope winds, right? We can see A. We see 4 degrees, 10 degrees, 8 degrees, 4 degrees, and the A is descending. So again, slope wind A would be Katabatic wind. They also accept downslope wind or gravity winds, but just let's stick with Katabatic winds. Said one factor that is responsible for the movement of slope wind A, as shown in figure 9.3. So again, similar to the last question or the previous example, because it's cold air, it becomes dense and sinks, right? There's also influence of gravity, and there's a pressure difference that exists at the crest and the valley floor, or yes, and there's a pressure gradient, right? And then what impacts do the uneven slopes have on the air moving downslope? So that means there's friction because the slope, as you can see from the image, is ruggedy. Excuse me, there's friction, and then that's a slower downward movement of the air itself. And it says explain why a temperature inversion occurs in a valley. So you can see that temperature inversion where it goes from 4 from the valley floor to 8 to 10 and back to 4. So why is there temperature inversion there? Because the dense cooler air collects on the valley floor, and then the warm air is therefore displaced upwards. And then in the paragraph discuss how slope wind A can have both a positive and negative impact on vegetation growth and on the valley floor. So I'll just do that next slide. So now we're going to look at the question. The positive influence on the valley floor is that radiation fog covers the valley floor, which increases the level of moisture that is available to plants. The melting frost is a source of water, which keeps the soils moist. Extreme cold will kill unwanted pests, and then the lower temperature promotes frost-resistant type of vegetation. Negatively, the floor condensed air collects on the valley floor, which creates frost pockets that destroys vegetation. And then the air cools to below freezing point, and frost covers the plants and soil, which weakens stems and leaves of vegetation. We have black frost that destroys plants, radiation fogs, which reduces the level of photosynthesis in the morning. Then we have reducing the variety of crops that are able to be grown. Only frost-resistant crops will be grown. So again, this is, I don't want to say general knowledge, but you can be able to just think about it logically about the effect of the frost, the effect of the fogs, the effects of the extreme cold temperature, and what that would do to the crops that exist there. All right. Okay, so we have come to the end of the video. Thank you so much for watching. We will go on to the next video looking at urban climate. And again, do not forget to like, subscribe, and share with your friends and comment any questions that you might have. See you next video. Bye.